Hello Year 6 and the rest of Bluecoat. It's Mr. Harris here, and I'm really sad because I'm bringing you your final Science at Home lesson, because in September you're going to be doing science in school, which is much better. Children, this is about the 11th week of Science at Home, so if you've got some time over summer, I'd love you to try and do some of the other experiments that we've done. They're super fun, they're super simple. Remember, check with an adult though. Okay, we're going to look at today's lesson now. I'm going to turn away from you. As ever, we do a recap. So, last week we made some dirty pennies into shiny, bright pennies. We're going to look at why, so you need to fill in the gaps. So, pennies are made out of a metal called mixes with which is the same gas that we breathe. This process is called oxidation. Oh, I've just given you one. And causes the coins to get dirty. The lemon juice has in it. When the coin goes in the juice, the acid with the copper oxide on the pennies and it. Okay, so there's some words for you to fill in there. Have a go at them now. I've given you one just as a helper. So, the first one. Pennies are made out of copper. Well done, you got that one. Metal called copper. Copper mixes with oxygen, which is the same gas that we breathe. It's what we need to be on this planet. This process is called, I gave you that one, oxidation. The lemon juice has acid in it. We've seen that in some of our previous experiments and how powerful it can be. When the coin goes in the juice, the acid reacts with the copper oxide on the pennies and dissolves it, making it nice and shiny. Remember, look back at that one if you haven't done it as yet. Okay, today you're going to need an egg, some water, a tall drinking glass, some salt and some spoon. Some spoons, one spoon will be fine. Don't need any more than that. Let's look at the science first. Okay, in the lava lamp experiment, we spoke about density. And the density of an object relates to its mass, which means how heavy it is, compared with its volume. That's the amount of space that it takes up. Now, if an object is more dense than the liquid it is in, then the object will sink. But if the object is less dense than the liquid it is in, then it will float. And we're going to look at an example now. Okay, so I didn't say you needed this in your experiment, but I have a table tennis ball here. I'm going to just simply place it in my cup of water. And you can see clearly that it floats. Why do you think the tennis ball floats? Is it more dense or less dense than the water? So there's a sentence starter. Because the table tennis ball is floating, it is less dense, more dense than water. Which one is it? That's correct. It's less dense than water. And now we're going to have a go with the egg. I mean, I'm feeling these two objects. And this definitely feels less heavy than the egg. But do we think the egg is going to float? So, I'm going to try and place it in now. Have to be careful with this because I don't want to crack the egg. And sure enough, you can see that the egg has sunk. What does this tell us about the egg? That's that it is more dense than water. But we're going to change something now. I've just gone through what we said there. We're going to make some changes. Let's see what salt does, because we just use normal tap water. So, children, you're going to need a fair amount of salt for this. Please don't use it all up. So that's why you should be checking with an adult. I've checked with Hannah. She says it's okay. And I'm going to pour some salt in my water. Okay, now it's quite important. You can see it's gone a bit misty. We want it to dissolve in here. So I'm going to stir it. Stir. Maybe I put too much salt in it because it looks very, very clear at the moment. Okay, so I'm going to now place the egg in this water. Okay, children, I'm back. I actually paused the video just to show you that the water now the salt rather has dissolved in the water, so we can't see it, but I wonder if it's there. So now I'm going to get my second egg. Of course, if you wanted, you could take the egg from that one and see what happens, but I'm going to put the egg in now and let's have a look. And there you have it, children. We have one egg that is at the bottom, and we have one egg that is floating. Let's have a look at why this has happened. Think about what we spoke about above. So the egg is denser in just the normal tap water, so it's heavier, which means it sinks. When you dissolve salt in the water, you increase the water's density. You increase how heavy that water is. As you dissolve enough salt in the water becomes more dense than the egg, and the egg floats. Now, I've seen something else happen before, and I'm going to have a go at it. I haven't practiced before, so I'm going to try pouring some water. And there, children, it's actually worked. You can see that the egg is kind of in the middle. It's suspended in the water. So what I suspect might have happened here is that the fresh water that's on top, the tap water, has not mixed in with the salt water, hence why it's just in the middle. Is that one floating or has it sunk? An interesting question. Okay, we're going to end it there. Just the usual. Some other things you can try. Try it with a different liquid, such as vinegar or maybe even cooking oil. Definitely speak to a parent about that. Does this make a difference to the egg floating or sinking? Can you dissolve anything else in the water to affect its density? So anything other than salt? What else have you got? Love to see some photos and the year group email. That's it from me. Science is over. Enjoy your summer. Take care. Bye.